Hello everyone, welcome back. So this time we are learning about density and specific weight. Now hopefully you know what density is, hopefully you know what specific weight is, but if you don't, that's why you're in this class. So let's get to it. So density is the amount of stuff that we can fit into a particular volume. I don't really have a good place for my head this time, so you know what? Bye-bye. Okay, so density is the amount of stuff we can put into a specific volume. For example, you might be able to easily lift an empty suitcase, but your filled suitcase is another matter entirely. It's much more dense. All those clothes and bricks and random power tools. Okay, maybe your suitcase is different than mine. Don't fit into that suitcase. So their densities are far different. And because of that, their weights are different. Now the equation for density is like this right here. It's mass over volume. Mass over volume. And that row right there, that row, I actually don't know that's a row, so it's a Greek letter rho. It looks kind of like a P without the little hat. That's the symbol for density. It's equal to mass over volume. So if you look at these two cases right here, we have the same volume both times, but one of those boxes has a whole lot more stuff in it. As a note, density is three-dimensional. I'm drawing on a two-dimensional page, so these are squares. Just visualize with me that they are filled with some sort of three-dimensional state. And what you can guess is that the one that has a lot more balls in it is going to be a lot more dense. So we have 8 of these, 1, 2, 3, 4, 5, 6, 7, 8, so 8 kilograms, and a volume of 2 meters cubed. So mass over volume. So 8 kilograms divided by 2 meters cubed would be 4 kilograms per meter cubed. And this other one, even though it takes up the same volume, the same space, it's much less dense because there's a lot less in it. Empty suitcase versus filled suitcase. Don't ever forget that. Okay, now I joked at the beginning that you would know what specific weight is, but I don't really expect you to know this. It's completely fine if you don't, because we're going to learn about it right now. Specific weight is super simple. If you look at the equation, your book says it's weight over volume, and that's true. It is the amount of weight in a particular volume. And you're thinking, weights of force, how do you have a weight in a volume? You have masses in a volume, and they have a weight. So you add up all the weights of the masses that are in your volume, and that's the specific weight. But the easiest way to remember specific weight is that it's simply density times gravity. That is a very simple formulation. So you just take whatever your density was, you multiply it by gravity, you have specific weight. And as a note, this is the Greek letter gamma. It kind of looks like a Y. Both of these are helpful to remember though. Weight over volume and density times gravity, because sometimes you need both to solve a problem. Okay, so let's look at this example over here. Once again, we have weights, which in these cases are going to be 9.81 newtons, because these are still 1 kilogram weights. And gravity is going to be 9.81 meters per second squared. So with that in mind, we look at all of these. Well, you see that we have the same weight in both these boxes. However, while this one right here is 2 meters cubed, this other one is only 0.5 meters cubed. And you can see that I tried to visually make it at least, somewhat proportional to the volumes. So it's 0.5 meters cubed. So if we do our calculations, what we get is weight over volume. So we have to add all the weights together, so that's 2 times 9.81 newtons in both cases. And then we divide by the volume. One is much bigger, that is much smaller. And you can see that my specific weight right here is much higher than the specific weight in the other case. And that's all because it is more dense. If I were just to calculate the density, remember that each of these little blue balls is 1 kilogram. What I get is 2 kilograms divided by 0.5 meters cubed. And that equals 4 kilograms per meter cubed. Okay? And this one right here is 1 kilogram per meter cubed. So you can see that this is 4 times as dense, and therefore it has 4 times the specific weight. Okay, density, specific weight. Density, mass in a volume. Specific weight, the weight of all the masses in that volume. What volume you choose is important. So I hope this helped you. Next time we're going to learn about something absolutely amazing called specific gravity. I'll talk to you all about that next time. Bye-bye.